The 5G revolution has begun, and the first lines of phones that can access the next generation of wireless speeds have already hit the shelves. Researchers at the University of Texas at Austin and the University of Lille in France have built a new component that will more efficiently allow access to the highest 5G frequencies in a way that increases devices' battery life and speeds up how quickly we can do things like stream high definition media. Smartphones are loaded with switches that perform a number of duties. One major task is jumping between networks and spectrum frequencies like 4G, Wi-Fi, LTE, Bluetooth, etc. The current radio frequency RF switches that perform this task are always running, consuming precious processing power and battery life. The newly developed switch is more than 50 times more energy efficient compared to what is used today. It can transmit an HD TV stream at a 100 GHz frequency, and that is unheard of in broadband switch technology. The research team published their findings in the journal Nature Electronics. The new switches stay off, saving battery life for other processors unless they are actively helping a device jump between networks. They have also shown the ability to transmit data well above the baseline for 5G level speeds. Prior researchers have found success on the low end of the 5G spectrum, where speeds are slower but data can travel longer distances. But this is the first switch that can function across the spectrum from the low-end gigahertz frequencies to high-end terahertz frequencies that could someday be key to the development of 6G. The UT team's switches use the nanomaterial hexagonal boron nitrite. It is an emerging nanomaterial from the same family as graphene, the so-called wonder material. The structure of the switch involves a single layer of boron and nitrogen atoms in a honeycomb pattern, which is almost 1 million times thinner than human hair, sandwiched between a pair of gold electrodes. The impact of these switches extends beyond smartphones. Satellite systems, smart radios, reconfigurable communications, the Internet of Things, and defense technology are all examples of other potential uses for the switches.